Hi everyone, today we are going to learn about the unit circle, but before we get started, I would like you to please go ahead and do this really quick warm-up. For this warm-up, I would like you to solve for x, just two plain equations. So go ahead and pause the video, and once you have paused the video, solve for x, go ahead and restart it, and we'll see how well you did. All right, let's go ahead and check your answers. So we have 3x plus 25 is equal to, hopefully you used the distributive property and ended up with 2x plus 2. At this step, I'm going to subtract 2x on both sides, and I'm going to subtract 25 on both sides so that all of my x's are on one side and all of my regular numbers are on the other. And when you do that, you'll end up with x is equal to negative 23. So negative 23 is your answer. And hopefully you did pretty well with that. For the next problem, we have ourselves a quadratic equation. So that means I'm going to start off by factoring this quadratic into two parentheses. And I'm going to split apart the 5x squared into a 5x and an x. And then I'm going to look at the factors of 2. My goal is to somehow get a negative 9. And I know that 5 times 2 is 10, and 10 is 1 away from 9. So I'm thinking that I'm going to put a 2 on the outside and a 1 on the inside. And since I want a negative 9, I'm going to make the 2 negative, because 5 times negative 2 would be negative 10. And I'm going to make the 1 positive. Negative 10 plus 1 is negative 9. So now what we would do is you would set each parenthesis equal to 0, and you should have ended up with your x values equaling negative 1/5, or x is equal to 2. So hopefully you got both of those equations correct. So now we are officially starting the unit circle. Now the unit circle is one of the most useful things that I could possibly teach you in trigonometry. It is the foundation for trigonometry in pre-calc or algebra 3 with trig. So the unit circle is a circle where the radius is 1 unit and it is placed on an xy coordinate plane. So your unit circle is 1 unit as your radius, or your radius is equal to simply 1. The angles are measured on the positive x-axis and measured counterclockwise, just like all of the other positive angles that we've talked about the last couple of days. The x-axis corresponds to your cosine function, and your y-axis corresponds to your sine function. So every ordered pair is going to be the cosine of theta is going to be your x value, and the sine of theta is going to be your y value. Now, theta is going to be one of our angles that we had from our special right triangles. It'll either be 30, 60, or 90 degrees, or it'll be from our 45, 45, 90 triangles. So the cosine, let's say that theta was 30 degrees. During our very first lesson of this unit, I asked you guys to please study a table because the cosine of theta, or cosine of 30 degrees was 1/2. The cosine of 30 degrees is square root of 3 over 2. So the square root of 3 over 2 would represent your x value of that ordered pair. And sine of 30 degrees is 1/2. So your ordered pair, the y value of your ordered pair would be 1/2. So today's lesson is not just learning about the degrees and not just learning about the radians, but it's also learning about the ordered pairs. And so cosine of theta and sine of theta, those values will come from that table that I gave you, which have been derived from our special right triangles. So getting it a little bit more in depth with the unit circle, we have the equation of a circle, or the equation of a unit circle, should I say, is x squared plus y squared equals 1. This is the equation of the circle. This is something that you guys learned about last year when we were writing equations for circles. It has a center that is located at 0, 0, and the radius is the square root of 1, which is 1. Our x-coordinate of each point on the circle is the cosine of theta value. So whatever the cosine of that angle that is created, so that's going to represent your x value, and your y value, or your y-coordinate, is going to be the sine value of the angle that you are looking at. And just know that tangent of theta, tangent is equal to opposite over adjacent. So your opposite is, in terms of SOHCAHTOA, the part that contains opposite is going to be sine of theta, and your adjacent is included in cosine of theta. What I want you to really think about when it comes to this is think about slope. Slope is equal to, it's your change in y divided by your change in x. And if sine is supposed to be y and cosine is supposed to be x, then that your tangent is going to be represented with slope. So it's going to be y over x, sine over cosine. And the way to remember which one's going to be which is think about alphabetical order. C comes before S. So your ordered pairs are going to be in alphabetical order. So that's going to be your ordered pairs. Cosine comes before sine. So whenever we speak of learning the unit circle, we are expecting you to be able to fill in the following. Every degree measure for every special angle going all the way around the circle. So that's going from 0 degrees all the way through 360 degrees. And you'll need to name those for every single special angle. So for all 30, 60, and 90 angles and 45, 45, 90, and 45 and 90 degree angles going all the way around the circle. We're also going to be expecting you to know your radian measures for all of your special angles. And that's going from 0 pi all the way to 2 pi. Being able to identify all of those values going all the way around the circle. And on top of that, the new thing that we're going to be talking about is your xy coordinates. So that's cosine of theta and sine of theta. I'm going to be looking for you to write all of those ordered pairs. Now, I don't want you to be nervous about this because it's really not going to be that bad. All of the cosine of theta and the sine of theta, once you have that first quadrant down, you'll notice that there's going to be a lot of repetition that is taking place. So I strongly recommend to memorize the first quadrant. If you know the first quadrant, then you can fill out the entire unit circle with ease. So just memorize the first quadrant. That's going to be essential. Now there does exist other types of angles, and those angles are called quadrant angles. And quadrant angles are simply angles in standard position whose terminal side actually ends on an axis. So your axis angles, those are going to be your 0 degrees, your 90 degrees, your 180 degrees, 270 degrees, and 360 degrees. Those are your quadrant angles. They land actually on an axis. And a quadrant angle is always multiples of 90 degrees or pi over 2 radians. And we've talked a lot about pi's over 2 radians because I've required you to write in all of your radian measures going all the way around your axes whenever we were drawing angles. So this should not be that bad for you. And the vocabulary word is just there called a quadrantal angle. That's just the fancy term for the degrees that we've already been working with. So now, the angles of the unit circle, which we've talked about in class yesterday, or earlier today. The angles of the unit circle, they are measured from the positive x-axis. And in order to create the unit circle, we are going to be working with the special right triangles that we learned in geometry and reviewed at the very beginning of this unit. The coordinates of the unit circle are the simplified form of the side lengths for the hypotenuse with a length of 1 unit. And then we're going to reflect the coordinates from quadrant 1, and we'll be able to find all of the coordinates for the rest of the special right triangles. So what I want to do is look at the first set right here. What we have here is a 30, 60, 90 triangle. So I'm just looking at this first picture. And on the 30, 60, 90 triangle, we have, if I were to graph 30, 60, 90, plot this triangle on here and identify this ordered pair. This ordered pair comes from going over a little bit and up a little bit. And since we have one unit, from our unit circle, we're going over x. X is going to be the square root of 3 over 2, and then up y, which is going to be 1/2. So that's where these values come from, our perfect right triangle, assuming that our radius is 1. So this ordered pair is going to be located at square root of 3 over 2, comma 1/2, because that's how you come up with an ordered pair. You go over x and up y. So that's what this ordered pair is. Now, on the other side, we're going to go over the square root of 3 over 2 and then up 1/2. But in a quadrant, your x values on the right-hand side are positive. Your x values on the left-hand side are actually negative. So this is going to be negative square root of 3 over 2, 1/2. So that's what this ordered pair represents. And notice that it's located at 150 degrees. So it's 30 degrees above 180 degrees. And so at that ordered pair, it's going to be negative square root of 3 over 2. If we were to reflect our triangle across the x-axis, this ordered pair right here, we're still going to go to the left, negative square roots of 3 over 2, but now we're going down 1/2. So our ordered pair is negative square root of 3 over 2, negative 1/2. And if we were to plot this triangle again, going down, notice that that is located at 330 degrees. That is 30 degrees away from 360 degrees, 30 degrees away from your x-axis. So your triangles are always flipped with respect to your x-axis. And this ordered pair, we're going to the right, square roots of 3 over 2. So that's going to be a positive square root of 3 over 2. But now we're going down 1/2, so that's going to be negative 1/2. So our ordered pairs are exactly the same. The only thing that changes is whether or not x or y is positive or negative. And that's something that we're going to be talking about a little bit more. There exists a little bit of a trick in order for you to remember which one is going to be positive and which one's going to be negative. But notice that bow tie that I showed you guys earlier today in class. That bow tie appears. And all of those are your 30-degree angles. Falls into that category of being a 30-degree angle. All right, so now I'm going to go ahead, instead of talking about the others, I'm going to flip the page and I'm going to fill this out on my unit circle. So on my unit circle, we're going to fill out our quadrant angles, and I'm going to use a different color. So for all of these, I'm going to be working with a different color. So I have a black pen, a green pen, I have a blue pen, and a red pen. So I'm going to be working with all of these different colors to identify the different categories of angles. So the first thing I'm going to do is I'm going to fill out my quadrant angles. So I'm going to start off with 0 degrees, then we have 90 degrees, 180 degrees, down here is 270 degrees, and back around again we have 360 degrees. And in terms of your radians, we're going to have 0 pi radians. Up here is every 90 degrees is a pi over 2 radians. Across we have 180 degrees is pi. Down here at 270 degrees, that is 3 pi over 2. And then back around again, this is 2 pi. In terms of the ordered pairs, if you look at the very beginning of our circle, one radius going all the way to the very end, a radius is equal to 1. So our ordered pair, this ordered pair right here, is going to be located at going over 1 and up 0. So this is located at 1, 0. At the very top right here, we're going over 0 and up 1. So 0, 1 is that ordered pair. Back here, at 180 degrees, we're going to the left 1, so our x value is negative 1, and then up 0, so our y value is 0. And at 270 degrees, this ordered pair is going over 0 and then down 1, so negative 1. And those are your ordered pairs of your quadrant angles. Next, we just talked about our 30-degree angles. And our 30-degree angles, we have 30 degrees is located 30 degrees away from the axis. 150 degrees is located 30 degrees away from the axes. 210 degrees is located 30 degrees away from the axes. And 330 degrees is located 30 degrees away from our x-axis. So it's all about how far away is the angle from the x-axis. In terms of our radian measure, so a radian measure, we have pi over 6 is every 30 degrees is a pi over 6. So I have pi over 6, and then I know over here this needs to be 6 pi over 6. So the one just before it needs to be 5 pi over 6. So this is 5 pi over 6, 6 pi over 6. Down here is 7 pi over 6. And then over here we are talking about 2 pi. So 2 pi with a denominator of 6 is 12 pi over 6. So 1 less is going to be 11 pi over 6. And that is your radian measure. Next we have the ordered pairs. And our ordered pairs are going to be, we're going to go over the square root of 3 over 2, up 1/2. So our x value is going to be longer than our y value. So that's going to be the square root of 3 over 2, 1/2. On the other side, our x values are negative, so this is going to be negative square root of 3 over 2. But our y values are positive, so that's going to be 1/2. Down here, this ordered pair, we're going to the left, negative square roots of 3 over 2, so that's negative square root of 3 over 2, and down 1/2, so that's going to be negative 1/2. On the ordered pair for 330 degrees, or 11 pi over 6, we're going to the right, square roots of 3 over 2, and then down 1/2. So that's going to be the square root of 3 over 2, and then negative 1/2. And those are all of your ordered pairs for your 30-degree angles. And they all fall in the exact same category. And if you want, you can outline the lines in the color that you chose, if you ended up choosing a color. So I'm going to outline my 30-degree angles in green, just to show that they are connected to one another. I'm going to use a straight edge in order to do that. Just to make it colorful. All right, next we're going to go ahead and talk about our 30, 60, 90 triangles, but we're going to talk about 60 degrees. So we're still working with a 30, 60, 90 triangle. We're still working with that. The only difference this time is we are creating a 60-degree angle with the x-axis. So this is a 60-degree angle. And in order for us to identify this ordered pair, we are going over 1/2 up square roots of 3 over 2. So this is going to be, our x value is 1/2, and we're going up, or our y value is going to be the square root of 3 over 2. So that's our ordered pair. Over here, instead of making this a positive, our x values are actually negative. So we're going over negative 1/2 and then up positive square roots of 3 over 2. So our ordered pair is going to be negative 1/2 and then positive square root of 3 over 2. So that is this ordered pair. And that's created with reflecting our special right triangle, creating once again a 60-degree angle with our x-axis. If we were to reflect our triangle across the x-axis, this ordered pair down here would mean that we would go to the left 1/2 and down square roots of 3 over 2, giving us an ordered pair of negative 1/2, negative square root of 3 over 2. So that's this ordered pair. And then the last ordered pair means that we're going to the right 1/2 and down square roots of 3 over 2. So 1/2 will be positive, and our square root of 3 over 2 will be negative. And that is our ordered pair. So now what I'm going to do is I'm going to go ahead and flip over to the unit circle and fill in this information. So I'm going to pick out a different color. So I'm going to choose red this time. And every 60 degrees, I'm going to fill in all of my 60-degree angles. So 60-degree angles are going to be divisible by 6, or 60. So 60 degrees, adding another 60 degrees will give us 120 degrees. Adding another 60 degrees will bring us to 180. Adding another 60 degrees will bring us to 240 degrees. Oh, excuse me. And then from here, adding another 60 degrees will bring us to 300 degrees. And then we're back to 360 degrees. So these are all of our 60-degree angles. Every 60 degrees is another pi over 3. So pi over 3 is associated with 60 degrees. So I'm going to add pi over 3 every single time that I travel 60 degrees. So traveling 60 degrees, I'm going to end up with 2 pi's over 3. Traveling another 60 degrees will bring me to 180 degrees, and that will be 3 pi's over 3, which is still 1 pi. Adding another pi over 3, we now are at 4 pi over 3. Adding another pi over 3, we're at 5 pi over 3. And then adding another pi over 3, we're at 6 pi over 3. And 6 pi over 3 is 2 pi. All right, so those are all of our 60-degree angles measured in degrees as well as radians. So now we're going to go ahead and fill in our ordered pairs. Now for our ordered pairs, we're not going over very far. Remember that 1/2 is a lot smaller than the square root of 3 over 2. So we're going over just a little bit, so that's going to be 1/2 is my x value, and then the square root of 3 over 2 is how far we're traveling up. So 1/2 and then square root of 3 over 2. So that means that this ordered pair, our x values are going to be negative, so that's going to be negative 1/2 and positive square root of 3 over 2. Down here at the next red location, we're going over, so that's negative 1/2, and then down, so negative square root of 3 over 2. So we have negative 1/2, negative square root of 3 over 2. And then this ordered pair, we're going to the right, so positive 1/2, but down square root of 3 over 2. So that's 1/2, negative square root of 3 over 2. And those are your ordered pairs for 60-degree angles. So now I'm going to take out my straight edge and I'm going to connect my angles, or connect my lines with this using the same color. Those are my 60-degree angles. Now I have one more set of angles that I need to talk about, and those are my 45-degree angles. So my 45-degree angles, I'm going to be working with a blue pen. So looking at my last set of angles, a 45, 45, 90 with a unit, where the hypotenuse is 1 unit, where we have our side lengths, which are the same because this is an isosceles triangle. They're both the square root of 2 over 2. So in order for me to identify the ordered pair of 45 degrees, I'm going to go over the square root of 2, up square root of 2. So that is my ordered pair. And I'm just going to reflect this special right triangle across the y-axis and across the x-axis in order for me to come up with my other angles. So the ordered pair here, we're going to the left, which is negative square root of 2 over 2, then up square root of 2 over 2. Those are your side lengths of that special right triangle. And so I'm going to write negative square root of 2 over 2, comma positive square root of 2 over 2. And that is your ordered pair for that for 135 degrees. Then if we were to come up with another or if we were to come up with our ordered pair for 225 degrees, we are reflecting the triangle across the x-axis. And we're going to go to the left, or backwards square root of 2 over 2, and down square root of 2 over 2, meaning that both of our x and y values are going to be negative. Square root of 2 over 2, I'm sorry, negative square root of 2 over 2, and then negative square root of 2 over 2. And that's our ordered pair. And finally, the last ordered pair, we're going to the right, so positive square root of 2 over 2, but down square root of 2 over 2. So that's negative square root of 2 over 2. So our ordered pair is positive square root of 2 over 2 and negative square root of 2 over 2. So I'm going to go ahead and fill up my unit circle. And in my unit circle, I have 45 degrees, so every 45 degrees, I have 45 degrees plus 45 degrees is 90, plus another 45 degrees, that is 135 degrees. Then remember that in between each little gap is 15 degrees, so if nothing else, you can always take 210 and add 15, and you'll end up with 225 degrees. I'm going to take 300 and add 15, and that's going to be 315 degrees. That's a little quick shortcut in order for you to come up with your degrees. And all of the 45-degree angles will end in a 5, so that's something to keep in mind. Also, all 45-degree angles are also pi's over 4. 45 degrees starts with a 4. That's one way to remember that. And we have, every 45 degrees, I'm going to add a pi over 4. So 45 degrees, I have 2 pi's over 4, which is pi over 2. So this one has got to be 3 pi's over 4. Adding another pi over 4, that's 4 pi's over 4. Adding another 45 degrees or another pi over 4, we now have 5 pi over 4. Coming around, I have 6 pi's over 4, which is 3 pi's over 2. And then this last one is going to be, this is 6, this is 7 pi's over 4. And then finally, if we were to add another pi over 4 or 45 degrees, we would end up at 8 pi over 4, which is 2 pi. In terms of our ordered pairs, this is probably the easiest one to remember, and that is going to be the square root of 2 over 2 and the square root of 2 over 2. So that's your x value and your y value. Over here we have negative square root of 2 over 2, positive square root of 2 over 2. All of our x values are negative, all of our y values are positive. In this quadrant, notice that all of our x values and y values are negative. So that's going to be negative square root of 2 over 2 and negative square root of 2 over 2. And in our fourth quadrant, all of our x values are positive, but all of our y values are negative. So that's the square root of 2 over 2, negative square root of 2 over 2. That is a pattern. I know that in the past when I taught this, some kids will fill in all of their ordered pairs and then work with the negatives last so that they remember that all x values are negative and all x and y. They figure that out as a pattern, and that ends up saving them time as they're filling up the unit circle. So now I'm going to draw a line connecting all of my 45-degree angles together. All right, so congratulations, you've just filled out a unit circle. This is everything that you will need to know for your unit circle test. This is the first part right here. So what might be helpful, I'm going to flip back to this page right here. What might be helpful is to remember your signs when it comes to your quadrants. So what I would recommend that you do is that you memorize quadrant 1, and once you know quadrant 1, you'll be, like in terms of your ordered pairs, you know everything else. The thing that changes is just your signs. So this is what I want you to do. I'm going to have you guys draw your picture. And in your picture, we have your positive value, or your x values are going to be positive, your y values are going to be positive. And if you were to multiply your values together, you would end up with a positive answer. So everything is positive in this case. Over here, all of your x values are negative and all of your y values are positive. And if you were to multiply your x and y values together, they would end up equaling a negative number. Down here, your signs are both going to be the same. Both of them are going to be negative. In quadrant 3, both signs are going to be negative. And a negative times a negative is equal to a positive. Finally, in quadrant 4, your x values are going to be positive, your y values are going to be negative, and a positive times a negative is a negative number. So that's a way for you to remember what your signs are going to be for the ordered pairs of your unit circle. All right. So now the final thing that we're going to be talking about is how to determine if our signs are going to be negative, our cosines are going to be negative, etc. And the best way to remember what's going to be positive or negative is this. There exists a phrase, and it's called all students takes calculus. So all students take calculus. I kind of just ran out. And what all students take calculus does is it helps us to identify whether sine, cosine, or tangent, which remember that cosine is your x values, sine is your y values, and tangent is y over x. So all students take calculus represents whether or not sine, cosine, or tangent is positive or negative. So in the first quadrant, everything, that means cosine, sine, and tangent are all positive. There is nothing that is negative. So everything is positive. So there's your all. So all signs are going to be positive in the first quadrant. In the second quadrant, remember that your x values were negative, but so all of your x values were negative. So that means that the only thing that is positive is your y values. So that is going to be sine. So sine is going to be positive. So that's your students, all students. But cosine would have to be negative. And if cosine is negative, remember that tangent is equal to sine over cosine. And if you have a positive divided by a negative, you end up with a negative value. So that means the tangent is also negative in the first quadrant. In the third quadrant, we have all students take. So in the third quadrant, both x and y are negative. So that means that your cosine values will be negative and your sine values will be negative. But your tangent values, which is y divided by x, or sine over cosine, which is a negative over a negative, will give you a positive value. So in this case, tangent is going to be positive, but your cosine and your sine are going to be negative. And finally, we have all students take calculus. So calculus is your cosine. Cosine is your x values. So your x values in this case are going to be positive. But your y values, your sine values are going to be negative. And therefore, if you have a negative divided by a positive, you end up with a negative value. So that means that sine and tangent are going to be negative in this case. So that's something to just keep in mind. So now, when you guys take your unit circle test, your unit circle test will have 6 questions at the very bottom that will look just like what you see here. And since you've already filled out the unit circle completely, it's going to be very easy for you to identify your answers down here. Try not to show too much work. That's the reason why I wanted you to memorize that table. But here we go. Let's say I asked you to find the sine of 135. You now know that sine represents the y value of the ordered pair. So I'm going to go to where 135 degrees is. I'm going to look at the y value, and oh, my answer is the square root of 2 over 2. Done. There's nothing further for you to do. Let's go ahead and look at the cosine of 210. Cosine, we know that that's the x value. So I'm going to go to where 210 degrees is. I'm going to go to where my x value is, and that's negative square root of 3 over 2. There's my answer, and I am done. There's nothing further for me to do. There's no work for me to show. Tangent of 60 degrees. Now, tangent of 60 degrees, If we were to go to where 60 degrees is, tangent, that's going to be equivalent to our y values divided by our x values. That's going to be our sine over cosine. So that's going to be the square root of 3 over 2 divided by 1/2. Now you can show all of this work if you would like. We know that to divide fractions is to multiply by the reciprocal, so that's going to be the square root of 3 over 2 times 2 over 1. The 2's cancel out, and we're left with the square root of 3 as our answer. But ladies and gentlemen, I would prefer you to just know that the tangent of 60 is the square root of 3. I don't want to see this work. It takes too much time, and I would mostly prefer that you just know that the tangent of 60 is square root of 3. So that's something that I want you to just know. Let's go ahead and look at letter D. For letter D, we have the sine of 11 pi over 6. Sine, we know that that's the y value of the ordered pair. Here's 11 pi over 6. 11 pi over 6, the y value is negative 1/2. So I'm just going to write negative 1/2 as my answer. Cosine of pi over 4, we know that cosine is the x value. I'm going to go to where pi over 4 is, and that's the square root of 2 over 2. Tangent of 5 pi over 4. So 5 pi over 4, we're talking about the square root of 2. So we have, for tangent we know is positive, and we're talking about negative square root of 2 over 2 divided by negative square root of 2 over 2. Well, it's the same exact number over the same exact number, so our answer is 1. I don't want you to necessarily show me this work. I just want you to know that whenever you're taking the tangent of a 45-degree angle, your answer is either going to be positive 1 or negative 1 every single time. So what I mean of a 45-degree angle is 5 pi over 4 is a type of 45-degree angle. Just know it's going to either be positive 1 or negative 1. That is it. Let's go ahead and look at the sine of pi. So if we were to go to where pi is located right here, and we're talking about sine. Sine is your y value, so your answer is 0. Cosine of 0 degrees. I'm going to go to where 0 degrees is. Cosine represents your x value, so the answer in this case is 1. The tangent of 2 pi. So 2 pi, that represents your y over x. So we're going to go 0 divided by 1. So this is 0 over 1, which is 0. Remember that 0 on the top is okay, but 0 on the bottom, no way. You cannot have an answer. We call it undefined, and if that were to be the case. And an example like that would be letter J. And letter J, we're trying to find the tangent of 270 degrees. So that's going to be y over x. So that's negative 1 over 0. And negative 1 over 0 is undefined. And that is your answer. That is the end of today's lesson. Hopefully you found that the unit circle was not that bad. We are going to be practicing the unit circle tomorrow in class more in depth. But if you have any questions over anything, please feel free to email me. I will see you next time. Bye-bye.